Hi everyone, welcome to the course of antenna designing using HFSS. Mainly, the title of this course is Antenna Designing, Learning Antenna Designing with the help of equations. But anyway, in order to differentiate from my earlier courses, that's why I'm telling you this antenna designing course using HFSS. So till now, we have covered three modules, starting from introduction, then parameters, then feeds and losses. Then now we are coming on to the microstrip patch antennas. Okay, so in this module also some key highlights I have mentioned, which be MP mechanism, that is microchip patch antenna mechanism, methods of analysis and resonant modes. Okay, so let's start with the theory. Like microchip patch antenna, we all know it's a traditional antenna, but now it is replacing the all conventional types of antennas like dipole, monopole. Okay, and Yagi the log periodic for high bandwidth, high gains. So like these types of application also nowadays patch antennas are replacing and taking place in the new terms. And now also in smart devices also it is coming and trending a lot. Okay. Regarding the structure of the microchip patch antenna, it consists of mainly three layers. That is in which two layers is of conductive layer, which is in between a dielectric layer has been placed. Okay, so on top layer, with the top layer is known as the patch. Why it is called as patch? Because it is a piece of a copper layer or a conductive layer. It is not necessary that it will be covering the full dimension of substrate. No, not at all. Only a piece of a conductive layer will exist. And middle layer, as I've said, dielectric layer will be there, which is known as substrate. And in the third layer, it is known as the ground plane, which is generally or may not, maybe or may not be equal to the dimension of substrate. Okay, how you can define the dimensions or the thickness of that patch? Mainly the formulas are also there, which I have already shown you guys if I'm not wrong, but in case if it is not shown, in coming lectures we will show the mainly the thickness of the copper layer, or generally I'm taking name as copper. It is not necessary that only in case of conductive layer only copper will be there. Aluminium will also be there, and gold will also be there some places. Okay, so the thickness of that that conductive layer should be some minimum, which is known as 1 ounce or half ounce, that is 0.035 or 0.017. Okay, this thickness should be very very lesser than the lambda naught, means what is the wavelength at that frequency. Similarly, in the case of dielectric layer, the thickness of that substrate should lies between these range, which is from 0.003 lambda naught to 0.005 lambda naught. Okay, similarly in the case of ground plane, remember one thing here I wanted to note, that patch as well as ground plane both are conductive layer, so the conductive layer thickness should be same. Okay, this has to keep in mind. Okay, okay, regarding the applications of the patch antenna, that generally it is used in every aspect nowadays, in mobile communication, medical application, wearable devices, electronic gadgets, and so on. Some satellite communications also there. Okay, and nowadays phase array as well as now smart antennas are also will are in the stage where it will take a boom very larger pace. Okay, having so many of advantages, but then also it is having disadvantage which can impact your overall design, which is narrow bandwidth, low efficiency, low gain. Okay, anyway, low gain can be erupted once if you'll go for a array design, but at that time bandwidth will be again a constant. Okay, so either these two parameters both are has to be made to be a trade-off between these two parameters. Okay, now this is one kind of image I just wanted to include, nothing else. So it is also having a antenna embedded in it. It is one kind of a very small antenna, or you can say the very old phone. First of all, it is a keypad phone only, in which a very small antenna has to be placed, so that for calling and all purpose it can be easily be done. Okay, now regarding coming to the shapes, it can be anything. Shapes of for the patch: square, rectangle, circle, elliptical, cylindrical, spiral, anything it can be. Okay, it is not necessary that it has to be limited. Anything. Just you have to give a shape to the copper layer. That is nothing but a patch only. That's what I'm saying, that patch is nothing but a piece. Okay. Regarding the methods of analysis, regarding the methods of analysis, transmission line model, cavity model, and full wave model, in which full wave model is applicable to generally to all types model. Okay, so transmission line model is the easiest of all, and cavity model more complex, and full wave model is also most complex. Generally, whatever the CST microwave studio or solvers are there, these are nothing but full wave solvers only. Okay, as you can see, the brief description, brief differentiation I have depicted here in this case, like transmission line model is the easiest of all, and cavity model more complex, full wave model is the most complex. Okay. Similarly, because of its most complexity, it is having very accurate, very versatile. But in case of transmission line or cavity model, it is difficult to model and to analyze. And similarly, full wave model can be applicable to all, but transmission line model and cavity model is having some limitation in terms of application, where it can be applicable to such kinds of model. Okay, so you can study more on that. I have not included, just to give a brief insight, I have included these models. Okay, now further, the what is the mechanism of MPA, that is microchip patch antenna. We have seen the mechanism for the antennas, and that to a concept of two wire antennas at that time. Okay, so two wire antennas I have depicted that how it will behave, antenna will behave. Now let us see the mechanism in case of transmission line model. Now, why I am saying transmission line model, because this microstrip patch antenna, whatever the feeds are using, it's strip line, microstrip line. Okay, so that's why it is nothing but the transmission line only, in order to propagate or to carry that fields, so that the patch can radiate. Okay, mainly the radiation pattern, the reason behind the radiation pattern or the bandwidth is because of this fields, and that to fringing fields. Okay, now what is fringing fields? Basically, fringing fields mainly because we are using a finite conductor. Okay, so since it is a finite conductor, so after this is open ended at the end, so it will evaluate, it will come out from the conductor, and it will confine to the substrate, as you can see in the second image. Okay, so at the lower frequency, the frequency, these wavelengths will be higher, so field will also be traveling more. Okay, similarly in the case of higher frequency, fields cannot travel more, and it will be confined very strictly to the substrate. Okay, as you can study in the left side, I have included what is fringing effect. Like, due to the fringing fields, the radiator will be having electrical length larger than the physical length. Okay, so the electrical length in the equations also I will see that how effective length will be minus, will be subtracted uh, by from the delta L, that is called extension length, which is because of the fields. Okay, that has to be subtracted in order to get the physical dimension or the physical length of the length, because along the length only this field will come, not from the width. Okay, now, in case of microstrip antenna, the fringing will be determined by the ratio of the patch length to the substrate height, okay, as well as the dielectric constant, which dielectric constant we are using. In case of 4.3, it is very lossy, so substrate fringing fields will not have that much area to occupy, and again the gain will deteriorate also. Now, substrate In the case of fringing fields will be traveling from one medium to another medium, like from conductive to insulator or the dielectric. So suppose substrate to air also. So most part will remain in substrate and other will exist in air. So that will comes as a part of epsilon or effective. Now, that is, you have to get an effective value of both the epsilons are. Okay. And suppose if we are using an infinite conductor, then fringing will never occur because it will be carrying to that, and at the end it will be lost, but fringing field effect will not occur. Okay. So this is also one kind of, this is also nothing but a width of patch. This is length. Okay. Radiating 1, radiating slot 2, open ended it will be, and it will be confined to this ground plane. Okay. So more you can study on the Balanese book of page number 799. Okay. That you can study and you can realize more even much better way. Now coming on to the modes. What is modes? First of all, number of patterns a waveguide can propagate, then these patterns are called modes. What kind of patterns we are getting, and that too, what are dominant modes? Now dominant modes, which is having a cutoff, least cutoff frequency by which, or highest cutoff wavelength by which antenna will start resonating. Okay. Now frequency at which the propagation constant is zero is known as what? Resonating frequency only. Okay. Now, for example, if T10 mode in a rectangular waveguide having dimension A and B, the cutoff wavelength can be evaluated from this formula. Okay. That you can evaluate A and B dimension, whatever the dimension will be there, and the mode, that is m is equals to 1, n is equals to 0. That you can keep it, and once you will keeping the dimension, you will come to know the cutoff wavelength. Okay. Generally, in the patch antenna, TE10 will be the mode, fundamental mode. Okay. And other antennas like circular microstrip patch antenna is also having a TM11. Okay. TE10 is for basic, sorry, for it is basically for waveguide, not for patch antenna. For patch antenna, it is TM10. Okay. And horn antenna is TE10. Okay. So this is nothing but a circular microstrip patch antenna which is having a TM11, horn antenna TE10, regular microstrip antenna TM10. Okay. These are the modes. You can study more on that. Okay. Now we will start our circular microstrip patch antenna module, which is number 5. And in this case also we'll start with the introduction. What is the formula in order to calculate the radius of the patch, and what is CP, RACP and LHCP, that this we will see. So yeah, in case of RMSA, modes can be controlled by adjusting the, RMSA means rectangular microstrip antenna. Okay. RMSA is, as I've said, rectangular microstrip antenna. In that we can adjust the length, width in order to adjust the frequency, or the width in order to adjust the bandwidth. But in case of CMPA, we are having only one parameter, that is what? Radius only. So this is one kind of design which I have included, which I have made for my BTech project, actually graduate project, very long back. Okay. And if you change the radius of patch, it will change the resonating frequency also. So that is most constraint in the case of circular microstrip antenna, in order to get the proper impedance matching, proper resonating. This is also very kind of a tedious factor. Okay. Regarding the formula also, I have mentioned here, that is RP is equals to F divided by 1 plus 2H divided by pi epsilon r F, where F I have already also included its formula as 8.791 into 10 to the power 9 FR under root ER. Okay. Where FR has to be in hertz and H should be in centimeter. Okay. Now, circular polarization. What is circular polarization? As I've told you, that when the field vectors is having both components, linear and horizontal, means horizontal and vertical polarization, both are there, then we will say that it is having a circular polarization. Okay. Generally, in order to provide circular polarization, this can also be done 90-degree phase shift we have given in order for by lambda by 4 provided, and it is fed to the same square patch. Okay, so whatever the power we are giving, just same from the 90-degree we have to give, so that it will be having a both vectors 0 degree and 90-degree. RMSA and CMSA radiates linear wave by linear polarized waves conventionally, okay, with the use of linear conventional feeds. Now, circular polarization can be obtained if 90-degree time phase feed are provided. So 90-degree how we are getting? With the help of quarter wave feed only. Okay, this can be done easily. Now further, this is nothing but TM110 when we are getting 0 degree, 90-degree, 180-degree. TM210 means 0 degree and again 90-degree and 90-degree, which is having a 45-degree in between. Similarly, TM310, TM410, like that we will get with this separation of the field waves between the two. Okay. Higher modes in CP can also be generated by adjusting the spacing and angles of the feeds. That is, this kind of angles. Okay. So TM110 90-degree angle, TM210 as I've mentioned in this case also 45-degree or 135. Because it will be the multiple of 180 minus 45 will also be 135. Similarly, TM130 30 or 90, TM410 22.5 or 67.5-degree. These kind of modes can be generated with these examples. Okay, just you have to give the phase shift. Now, another way in order to produce the circular polarization, that can be done with the help of slots. Now, how you can put the slots? As I have said, that C by D and the ratio of the C by D should be like this. As you can study these formulas, then you will come to know. And that too, it is applicable only when in case of square patch, not in case of rectangular patch. Okay, so that time you have to keep in mind what should be the ratio of the C and D. Means C will be calculated by L divided by 2.72. Any length it can be. Okay. Similarly, D will be C by 10. Okay. C by 10 it has to be. Then it will be applicable. Coming on to the RSCP and LSCP means right hand circular polarization and left hand circular polarization. So both can be obtained by feeding along the diagonal. Means whatever the square patch we are having, you have to give in such a way that it is coming at the point of diagonal line. Okay, and one another way in order to change the feeding and all, varactor diode, which is for higher frequency diodes, it can be implemented to adjust the biasing, means adjust the voltage supply. Okay, so this can be done either at this or that side, so that you will be getting a circular polarization or RSCP and LSCP. Okay, now another method is also there, which is known as trimming method. Now how you will trimming method? Means in the square page you have to trim the cornered edge you have to trim. At that time also you will be having a circular polarization. Okay, now trimming of the corner patches in case of RMSA and making the circular patch slightly elliptical with stub can result the circular polarization. Now what is stub? Stub is nothing but this kind of thing where impedance will change, and modes will not generally change, but in case of polarization will change. And that too, since as you can see it is applicable to, it is applied when it is having a 45-degree angle. Okay, So we have covered the two modules in this session, that is fifth and sixth, microstrip patch antenna and circular microstrip patch antenna. Okay, I hope you have understood. And regarding any query, you can put in your chat box, and also you can email me your query even once it is course is ended. Okay, thank you everyone.